All right. So next up, we have a trapezoid that's written into a circle with radius 2 units long. You know, there's something about trapezoids that are sitting in a circle. They are always symmetrical. If you think about it, before we start the problem, the three sides are 1 unit, 1 units long, the radius is 2 units. Right. So before we get into the actual problem, let me tell you a little something about trapezoids written into a circle. Now, this is a chord. A circle, as you know very well, is the set of all points equally far from a fixed point, namely this one. And if we draw the perpendicular bisector of this line segment, that is the set of all points equally far from the endpoints of this line segment. Well, the center of the circle is one such point. It's equally far from these 2 points. So in other words, any chord's perpendicular bisector will contain the center of the circle. And so if you want to have a trapezoid, then let's say this is one of the parallel sides, then no matter where that parallel side is, it's going to be parallel. And its perpendicular bisector too will contain the center. So basically, they will have the same perpendicular bisector. And so a symmetric trapezoid, trapezoid that can be written into a circle is always a symmetrical one. I think even if you don't have this idea, your picture will kind of force it on you. So let's not waste this page. So we have a symmetric trapezoid where 3 sides are 1 unit long each. And we have to find a 4th side, and we're given that the radius is 2. This is an interesting problem because this problem is very different if we are asked for exact values. It can be done, but so if you think about in terms of arcs, these 3 arcs are congruent. Therefore, these 3 angles are the same. And so the way I would solve it is I definitely see a law of cosines here. If we state the law of cosines in this triangle, we know all 3 sides, and therefore we can find the cosine of this angle. So we can say, well, the law of cosines says c squared equals a squared plus b squared minus 2 times a times b times cosine gamma. That's the law of cosines. And then we can say this is going to play 1 here will play the role of c, and we're going for this angle here. Actually, let me just solve it in the abstract. So 2ab cosine gamma equals to a squared plus b squared minus c squared. And so cosine gamma is going to be a squared plus b squared minus c squared divided by 2ab. I find that very interesting that if you have a triangle with integer sides, then the cosines are rational. That is not true for the sines. So again, the personalities of sine and cosine are so strikingly different here. So what we're going to do is a is going to be the same as b and 2, and c is going to be 1. And we're going to find cosine gamma using this expression. So a squared is 4, b squared is 4, c squared is 1. And then we divide by 2 times 2 times 2. So we have 7 over 8. That's the cosine of gamma. Now, if we are asked for exact values, then we can find from cosine gamma, we can find sine gamma. And then we can find cosine of 2 gamma and then cosine of 3 gamma. And then we would conduct a law of cosines on this triangle where we know that this side is 2, this side is 2, and this is 3 times the angle. And we could actually find the exact value of cosine of 3 times gamma. But this problem is going kind of easy on us because it says we just want approximations, which means that from cosine gamma equals 7/8, we can actually find gamma and then triple it and then run with the law of cosines. So gamma is, we're just going to ask the calculator. Inverse cosine of 7/8 is 20, almost 29 degrees. You know, it's never a bad idea to store it just in case. We can erase it. So now this number is stored in A. And I'm going to say times 3 because the last answer was that angle times 3. That's 3 gamma. It's almost 90 degrees. Actually, the picture is not that bad. These angles are slightly too big. So 3 gamma is 86.8651, say. And now we're going to apply the law of cosines for this angle, and we're going to find this missing side. Again, it could play the role of C. So we could say C squared equals A squared plus B squared minus 2 times A times B times cosine of 3 gamma in this case, right? And so C is going to be the square root of A and B are still 2. So we have 4 plus 4 minus 2 times 2 times 2 is 8 times cosine of this 86.865. You know, it feels like it should be long. And indeed, we're subtracting. This number feels pretty close to 0 because cosine of 90 is 0. And so this is going to be a small number even after multiplication by 8. So we're not subtracting much from 8 before we take the square root. But this number, by the triangle inequality, we have to get something less than 4, right? So what we have, we can just punch in the whole thing as it is. That 86 is still in my calculator, so we can punch in the whole thing. Square root of 8 minus 8 times cosine of, and there is a button that says the answer, the previous answer, which is still sitting in my calculator, I believe. And then close the parentheses for the cosine and then for the radical. Ooh, that's a very round answer, 2.75. That is actually 2.75. Interesting. So let's see what the computer thinks if we enter $2.75. Yep, that's the one. We got it right. Excellent. Thank you for watching.